Okay, so welcome back to the video on SR latches. So what you have learned is what an SR latch is, how it can be built using NOR gates. You learn timing diagrams, you learn truth tables. All that is very important in order for us to proceed on to the next part. What is an SR latch used for? Okay, so, it's very important in certain applications. I'm going to be teaching you two applications. One is to remember a signal, and the other is to debounce a switch. Okay, more on that later. So the first part is remembering a signal. Now, just let's take a look at this situation, right? So if this was a burglar alarm, okay, if this was a burglar alarm, this is the switch over here at the window switch, and this is a BJT acting as a driver. And when this closes, what's going to happen is that this is going to go, sorry, did I say close? When this is open, when this is open, right? When this is slid up by the burglar, the the thief, uh, this is going to open. And when this opens, this will go high. And when this goes high, this allows the current to flow and the buzzer buzzes. Okay? Works all fine and dandy. But what happens is, what if the burglar, once he hears the alarm, he climbs in, he shuts the window again, this is now closed again, this goes low, the buzzer stops buzzing. So if you are a really heavy sleeper, right, the thief is the burglar, the robber is very fast. He opens, he climbs in, he shuts. The alarm just buzzes for maybe 2 seconds, and you being a heavy sleeper, which I know most of you are, that 2 seconds of alarm is not going to wake you up, right? You'll probably just hit something and think that, oh, it's gone, alarm stops, I've got the snooze button on, you go back to sleep, right? So that sucks because now the burglar is inside, the alarm is not ringing, and he's free to take whatever he wants from you. Okay, so to stop that situation from happening, what we're going to do is that we're going to put a SR latch in between the window switch and the BJT acting as a driver or a switch. Okay, so this is how it works. When the window is pulled up, okay, when the switch is open, this fella now goes high. Okay, when this goes high means the S is high. When the S goes high, the Q goes high. And when the Q goes high, this thing is turned on as a driver and the buzzer buzzes. And then the thief goes, shit, I need to close the window again. So he shuts the window down, the switch goes closed again, and now it is a low. Remember, this is a pull up logic switch, logic resistor, so this goes low. But remember, if 0 and this is 0, okay, this is 0, 0, 0, the output state will remain at the previous state. And in this case, it's a 1. So it remains as a 1, and the buzzer still goes on buzzing, even though the burglar has shut the window back down. And you'll be wondering, what is this fella for? Right? What is this fella for? So this is the logic switch connected to the reset. So if I am woken up by the alarm, okay, and I come down to the house, I want to shut that irritating alarm off. What I'm going to do is that I'm going to close this fella. This guy will now be changed to a logic 1. Okay, so now it's going to be a logic 1. And when a logic 1 at a reset occurs, the output will be reset back to a 0. And when this goes to a 0, the buzzer stops buzzing. Okay, so that's generally how SR latch can be used for, is to remember a signal. So even though it opens, close, right? This one will still be remembered as whatever previous signal that it was. Okay, so that is the first use of it, to act as a sort of like a remembering of a signal device. The second one use that I'm going to teach you is how to use an SR latch to debounce a switch. What does that mean, debounce? Okay, so you have to know that when I use a mechanical switch, we're talking about mechanical switches, when I press the switch or if I slide the switch, whether I'm using a push to make or a slide switch, if the different single pole, single throw, double throw, whatever mechanical switches I use, usually there is what we call a contact bounce. It's like when I want to close a switch, okay, when I want to close, sometimes there is that bounce that happens. And when this bounce happens, the signal bounces correspondingly. Okay, you'll be thinking, so what? So long as at the start I have a high and at the end I have a low, it's what I really want anyway. Yes and no. Sometimes the output works on falling edges or rising edges. So what that means is that the output will change every time it senses a falling edge. Okay, ideally I want switch one falling edge and it goes down. Okay, so at this point in time the output will change. Okay, you'll turn on something, something will happen. Okay, every time there's a falling edge. But if there's contact bounce, okay, what happens is that there are multiple falling edges, and with this multiple falling edges happens, the output will change multiple times as well. Sometimes it doesn't matter, sometimes it matters a lot. We want to avoid that situation. Okay, so this is what contact bounce is, and we want to avoid contact bounce. Okay, we want to avoid this up down signal as the mechanical switches changes from one point to the other. So what we are going to do is that we want a nice change in signal every time we either slide the switch or we push the switch. Yeah, we want this very nice change in signal. And how we do that is we use an SR latch. This is my SR latch to debounce it. You'll be thinking, how does that work? I'll be going to that in a minute. But for now, this is what we need. We need the switch. In this case, it's a single pole double throw. Okay, so it either flips from A to B or B to A. So this is the signal. It goes from A to B or B to A. These are pull down resistors, and these pull down resistors ensure that if it's a high, it stays at a very nice high, and if it's a low, it stays at a very nice low. Okay, so we covered this in logic switches in chapter 10, I believe. Okay, okay, so right now it is at position B, right? It is at position B right now, so this is going to be a high. Okay, so it's going to be a high. So when position B is a high, okay, sorry, at the start it's 0 0. Okay, so right now the output, sorry, the output is a 0 because my reset is a 1. Remember, over here my reset is a 1. It's a 5 volt, it's a high. So if it's a 1 0, this fella will be a 0. The output will be reset to a 0. Okay, so this is the situation we are in right now. Now, what happens when I flip this fella up? The action of flipping the switch up will also cause some contact bounce, right? When you press down, it bounces before it fully opens and leaves to the other position. Let me zoom in a little. When I have over here, yeah, when this fella bounces up and down, remember this is bouncing from a 1 to a 0, okay? But when it bounces down to a 0, okay, this is a 0, this is a 0, the output remains the same. It doesn't change, okay? The output doesn't change. So if it's a 0, it still stays as a 0. And when it goes all the way up to a 1, Okay, 1 0, it still stays as a 0. And when it goes back down to a 0, 0 0, it stays at the previous position, stays. So in this case, the bounce at the leaving contact will not change the output at all. Okay, so even though there is a bounce, it's just bouncing between 0 1 0 1 0 1. This fella stays at 0, no problem. All right, so it leaves contact B. Now it's going to go into contact A. So we have already settled it leaving contact B is going to go into contact A right now. When it hits contact A, okay, when it hits contact A, there is going to be some bounces as well. So what happens during the bounce? So this is it touching contact A, okay? So we are going to do the edge by edge. So as it leaves, the first time it hits a 1, remember now it's going to be a 1, 0. If it's a 1, 0, the output is going to go to a 1. Okay, 1, 0, S1, R0, Q output is going to be a 1. But wait, that's going to bounce back down to 0. So there's going to be a bounce down to 0. But here is 0, 0. It stays, it remains at 1 because the input state 0, 0, output remains at the previous state, which in this case is 1. It's going to bounce back up to a 1. So 1, 0, it still a 1. Bounce back down to a 0. 0, 0 remains at the previous state is at 0. So even though there is contact bounce of it leaving and there's contact bounce of it reaching the other contact, it's going to give me a very nice smooth signal like this. Okay, so basically what I've explained is point 1 to 5. If you're confused by what I said, I apologize. And you can read these points here. Okay, or what you can do is that you can pause the video, rewatch this segment again, and hopefully you get a better understanding. Okay. So now, review questions. Do you know what is the purpose of a debounce switch? Okay, so I don't know whether you're hearing the beeping sound in the background. I apologize. That's my other work WhatsApp coming in with messages. I should have stopped that from coming in. My bad. But review questions. So if you know that a debounce switch is to prevent the outputs from bouncing up from a high and a low and a high and a low, and to give me a very nice edge up and a rising edge and a falling edge as the input changes, yeah, you know the purpose. And do you know how to draw a circuit using a SR latch, NOR gate SR latch to build a debounce switch? If you do, try drawing it here in this empty space. And once you've done that, compare it to over here. Okay, so we've come to the end of the chapter on SR latches. Just a quick summary, okay? Just a quick summary. What we've covered in this chapter is what is an SR latch? How is it built using two NOR gates? Do you know how to hook it up? What it does and how is it used? So I taught you two uses. One is to remember certain signals so that the signal is not lost. And two is to build a debounce switch. Uh, Subset to the debounce switch, do you know what causes the bouncing of the signals? Do you know how to draw the debouncing, and do you know how to draw the timing diagrams of both the SR latch and the debounce signals? And do you know how to build it eventually when we hit the practical? Okay, so earlier on in the video, I did say that I'm going to teach you a shortcut, a pro tip in building a SR latch. Now, there are already IC chips that sell that already have this latch inbuilt into it, so you don't need to make so many connections between one NOR gate to another NOR gate. Um, And the IC chip that I'm talking about is the CD4043. There's going to be a video on it. I'm going to add it to this playlist, and you can check it out. It's quite easy to use, and I find it very, very convenient to use as well. If you still insist on doing it using two NOR gates, please by all means go ahead. All power to you. You'll notice I did not touch on using NAND gates to build the SR latches. You can build a SR latch using an NAND gate. I didn't cover it. Please go do your own research if you want to, but it's probably not going to be used during our practical sessions or coursework. Okay, so with that, I've come to the end of this chapter, chapter 13, SR latches. As usual, if you have any questions, please email me at yo_haig_jean at moe.edu.sg. Yeah, so this channel is for your own learning. Hope you learned something useful today. Ciao, ciao.